One of the benefits of application problems is that we get to draw a picture to conceptualize all the concepts that we're looking at. So we have a point A that's on the ground way over here, and there's a building that's pretty far away with a height of 29.7. Or excuse me, a height of h. We don't know the height. We have an angle up to that, so angle of elevation means from the ground, and that angle is 29.7 degrees. Alright, then they say we move 550 feet closer, so we're moving closer and we end up at point B here, and we end up with a new angle of elevation, which this time is 43.5. Alright, and we're supposed to find the height of the building, this thing I called h here. Alright, so we have a few ways of figuring out h. We know that this measurement right here is 550, and we have 43.5, which is the angle of a right triangle given one of the variables that we have, right? We have h as the opposite, so I can relate opposite to either the hypotenuse or the adjacent in order to find the variable we want here. So in other words, if I call this hypotenuse, let's call that x, let's say. We know that sine of 43.5 is equal to h over x. So if we can just find x, we can find h really easily by just multiplying by it. So in other words, h equals x times sine of 43.5. Alright, so let's find x. And notice x is shared between the triangles, so it would be pretty easy if I can figure out some information about this triangle to find out x. Now, this triangle right here, let's outline this in red. This triangle right here is not a right triangle. So, we can't just use simple trig functions like this. We have to be a little more creative about it. And the way I would do that is I notice that these two angles are complementary, or excuse me, supplementary. The angles here and the 43.5 are supplementary. That means they add up to 180 degrees. So if I call this angle, theta, then 43.5 plus theta is equal to 180. Just because they span a flat line like that. I can subtract and I should get 136.5. I want to double check that with a calculator. Gotta be careful with that kind of stuff. 180 minus 43.5 is 136.5. Awesome. Alright. Now that we know that angle, I can draw this triangle off to the side and we can see if we can figure out the rest. Something like that. This is 136.5. This angle is 29.7, and we know this is 550, and our goal is to find x, which is this distance right here. Notice that we have two angles, and that means we can find the third angle simply through subtraction. In other words, 180 minus 29.7 minus 136.5 is equal to, again, referring to my calculator here, 180 minus 29.7 minus 136.5 is 13.8. So this would be a 13.8 degree angle right there. Now that we have an angle in the opposite side, and we have the angle opposite to the side that we want to find out, we can use law of sines in order to figure that out. So in other words, x over sine of 29.7 equals 550 over sine of 13.8. The rest is just multiplication. So x is equal to sine of 29.7 over sine of 13.8 times 550. Just a little reorganization of the fraction, but note that that is just aesthetic. Nothing too important there. I'm just going to make sure to type this into a calculator correctly. One thing to make sure of when you're doing these calculations is that your calculator is in degrees. Because if it's not, you'll end up with a different number. Alright, the number I get is 1,142.41, let's say. The question doesn't tell us to how many decimals to round to, so we'll just go to 2 decimal places for now. Note that this is just x, so our answer, h, is x times sine of 43.5. So I go h is equal to, and I multiply that 1,142 times sine of 43.5. 786. And since our original measurements are in feet, then this is feet.